Hey everybody, this is Larry. Is it the last day? Yes, it is. June 30th, the last day of the June Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think, and if y'all here, hope you're here for the full 30 days. If not, I mean, you can look at my playlist or something and then just check it out. But whether you have a monthly streak or not, let's get this problem started. Remember that, we have I don't know what the streak is at nowadays. I guess it's actually on the screen. 820 day streak going. So that means that we're not stopping tomorrow. We're not stopping next month. I think, knock on wood. So yeah, join us, do the prompts together, and come to Discord. Post your code. So ask questions about it. Whatever you need to do. It's free, yay! Because a couple of people asked me like, but I'm just saying it's free. And I don't intend to do anything like that to charge. I mean, anyway, all right, let's get started. Today is the last problem. So minimum moves to equal array elements 2. So given an integer array nums of size n, return the minimum number of moves required to make all array elements equal. In one move, you can increment or decrement an element of the array by 1. Okay. So I think one thing that you can do is binary search, right? Can you? Well, you can definitely do a ternary search, which is not a common thing, but it's something that's my arsenal, and I do think about it probably more than I need to be. I think this is one of those problems that the thing that it reminds me of is a classic problem where basically you have a y or x coordinate. You have basically a one-dimensional line, and then you all try to figure out what is the best place to meet, right? And this is basically that problem where you can go left or right, and then you try to find, and the answer is going to be you could probably do and based on that visualization, even though and I think this is exactly the same problem, but with a easier visualization. Basically, as I say again, is the you have a one-dimensional line or a street or whatever, where you have all these people and you're trying to find where to meet. And I think by that there are two answers, right? One is okay. Actually, I was going to do some ASCII art, but while I'm at home, while I have this beautiful drawing, let's bring up my drawing pad. Hang on, and I think I have a good good idea for proof. We'll see if this actually works. Hang on. But yeah, so let's say you have this timeline, right? And then you have let's say you have something like this, and these lines are, and they're not equally spaced, they're like in all over the place, and then now you're trying to find out where to meet, right? So I think the intuition is that it's going to be the median, or well, okay, so let's do two cases, right? If I'm thinking about a median, then I'm thinking of, or like, let's do the odd case because it's easier to know what the median is, and then the even case. Okay, so let's say there's odd number of things we're trying to find the middle for, and then I think you can prove. I think this is the middle, and I think this is where you would put the numbers, right? Why is that? Well, the reason why is because if you move, let's say you move to the left one, right? What happens? Well, that means that to the right, that moves +5, and then everything to the left, right, is -4, right? So then by that means that by moving to the left one space, you're making your answer one space worse, right? And of course you can do the same for going to the right. I mean, I'll leave it up to you without a loss of generality. I like saying that, so that's why I'm saying it. But hopefully that makes sense as a visualization. right? And then of course, so that's the odd number, right? And I think I think this is good enough of a proof. Let me know if you want to add it on later. Let me try it. Now we have another one, right? And now let's say the even number. So maybe I should have spaced it out a little bit better, but anyway. So and I think this is still the median, but let's say we have 4 and then now the median. Well, I mean, I know that the various definition of median, but actually, if there's even number, all you have to do is just between the two numbers in the middle, right? Why is that? Same logic, right? Let's say we're here. Oops. Let's say we're here, right? Well, moving to the left one means that here we have +4, and here to the right we have -4, right? And of course, this is true for everything in the middle, right? And maybe I should have used a different color. And then of course, now let's say that we move to one of the numbers, let's say here, right? And then now, if we want to keep on going to the right, well, past this, that means that here it's going to be -5, and here it's going to be +3 because you're moving. Oh, sorry, the other way around. My fault. If we're moving to the right, then on the right side it's going to be -3 because that means that all those 3 people can move one step less, whereas +5 to the right or to the left. I don't know what I'm saying, but hopefully the visualization's right though. That means that everything to the left has to go one extra step if we're moving it one step to the right, right? So hopefully by this visual proof, we get the idea that yeah, we want the median. Also, I need to figure out how to space out my planning, my drawing a little bit better, because as you can see, I have so much space on top. Anyway, that's a little bit matter. So yeah, so now, and without a loss of generality, let me bring it back up for a quick second. That means that because on the bottom, the one on the bottom, we can go any number from here to here. That means that we don't need the true median. We could probably round down or round up because let's see, with this odd number, with 7 elements, if it's 0 index, then the number that's in the middle is 3, so it's divided by 2. Where if it's let's say there's 2 elements, and you could choose 0 and 1. If we do it by 2, it's going to be the one round up, but it doesn't really matter. So yeah, so that's good. And I want to say one thing. I'm lazy, so I'm going to do a sort, right? And then the median number is the element in the middle. Of course, you can optimize this with a median finding algorithm, which is O of n. There's O of n squared worst case. However, you can just randomize the input to make the worst case very unlikely, right? So that's basic. And you would add the randomization because you don't know, or if someone wants to give you a really bad input, they cannot if you randomize the input. That's basically the idea. At least not usually. I mean, you get unlucky, but they can't force you to be unlucky. I'm not going. I want to go over median finding right now. Yeah, I'm not going to go over median finding for this video, but if you have questions about it, let me know. But that's basically one way that you could do an n of n. However, I am a little bit lazy, so I'm going to at least, because I want to focus on not the median finding part, but just the part where we're coding. So yeah, so median-ish is equal to nums over 2, and then we just sum up for x in nums. Total is equal to 0. Total absolute number of x minus median-ish, and then return total, right? That seems okay. Let me just double check my n is equal to 0 cases, and because I feel like recently I've been really silly on edge cases, so let's quickly try a little bit more. Okay, looks good. Let's give it a submit, and then cool. Yeah, again, you can do this in the June batch. Nice. Yeah, again, you can do this in linear time, but this is gonna be n squared because of the sorting. But yeah, how did I do it last year? Did I do median finding? Oh, I did some crazy technology. What is going on here? Oh, huh. I mean, I guess I could do this. I know what I did last time. I guess last time I was a little bit not as sharp on the proof. What this is just figuring out a way to do brute force, which is, I guess, like if you didn't want to do the proof, doing brute force is pretty good. And then it's just basically choosing, okay, if this number is in the middle, then what is the cost, right? And then take the best cost. I think this is what this is doing. Still n log n, but yeah. Cool. I think that's pretty much all I have for this one. Let me know what you think. Cool. Yeah, have a great end of the month. Stay good, stay healthy, take your mental health. I'll see you later and take care. Bye bye.